The next step in our process, we go to the next item on our menu, pre-process, and we see three buttons here. Usually press all three in sequence. Convert STL to CDF. The CDF file is a particular file type that allows you to copy between different machines, whether Sun or Linux or many different kinds of machines. They're binary compatible, these files. The make STL adjacency graph tells the software how various STLs are connected together. Sometimes you want to have parts connected as though they were pre-welded. Sometimes you're going to weld them in this project, and sometimes you don't want them to be connected at all, that they can rub back and forth. And so we make an STL graph. Later on we will assign whether the parts are connected or not connected or welded. Run BRep analyzer. What this does is generate what we call a BRep, or it's a boundary representation of the part. Basically, each flat surface is split off into a patch, and the rest gets broken up into various patches, and these patches can be assigned various properties later on in the process, or they can be meshed and extruded and various things done with them. So that's that. We go to the next item. We can ignore the import right now. This is for importing results from different kinds of projects. For our simple example, we'll do the part adjacency I mentioned. Part adjacency, we see our body parts listed here, and over here we see two parts, part cross bot, which is our first one, and the adjacent part. And we have an adjacency type. Right now it's set to none. And over here we see a number of items. We can view the adjacent pair. Right now we are looking at the the mid and the bottom part, and we're just going to say those are connected. So we have here disconnected, connected, welded. These are going to be connected. That's as though they were pre-welded. Next, we see the names change. These are the same parts, only from the other perspective. What you can do here is simply turn off these other ones and say only show me the ones that have no assigned connection. So we go to our next item that has none, and view, and that is our mid and our top. Now we're going to weld along the edge of this top plate. We're going to weld the top plate to the mid plate. So I'm going to say that this is welded. Now there are no more nones. No more types of none found, so we simply have three parts. One of them we said was connected, the other one is welded. Apply OK, and we go down our list to part attributes. Part attributes is very important. This is where you actually mesh the parts. For each of these parts we can look at our BRep. We have the BRep that we made first is basically a default BRep type. There are several other types, as you can see. But just over here we can say view parent and view child. In our case, our geometry is fairly basic. It's just a rectangle. But you see the different colors. These are different patches. And you can see under the visibility window and parts that we have, I can tear this item off. We have the patches listed here, and we can turn them off And by turning off this, clicking on this list or back on, whatever, we can view our parts. Now usually we want to mesh the large part. This software was originally intended for sheet metal parts, and so there are many things that are set up to make sheet metal meshing easy. So what we often do is mesh the largest patch and extrude it to the next largest patch, which is convenient if your thing is similar to sheet metal. That's the BRep. We have a number of other items here that I'll ignore for the time being. The other one is the mesher type. The easiest one to use is the general sheet metal mesher. There's a number of other types of mesher here. The general sheet metal mesher has a few options. This is the short list, actually. If we look over in our project preferences, we can click on the edit advanced parameters, and this will give us a much more detailed list of parameters. If I now click on options, you see I have a much longer list. Usually you don't need to see all of these items. The short list is often enough. Now the software has made a guess at how thick our part is, and you see this number here. More likely can be shortened to 1 centimeter thick, and it has made a guess at the minimum and maximum element lengths. For now we can accept these. Okay, and we have a mesh make button and a mesh view. I'll rotate so we can see a little bit more. We'll turn the mesh on, and this is the mesh that has been made. Now this is formed by the large size that we suggested in our options. We can change these things simply by changing the minimum maximum. Let's make our maximum smaller, make it the same as the minimum, for example. Make our mesh again, and you can see much smaller elements. Now these general sheet metal are this particular mesher gives you a rather strange mesh. There are other meshers, for example the PQ surface mesh is one that is a little bit more complicated to use. We won't go into it in detail at this point, but it gives you a much more regular mesh. But the general sheet metal is easier to use, but the quality is a little less, but certainly sufficient for running the analysis that are usually required. So I'm just going to accept the defaults on these parts and make the 3 different parts. Each of these parts can be viewed separately, or you can go to the merge body over on the far right, merge body and view body. Now we have the 3 parts together, and we have meshed them. Now you see the one we did at first, we changed the parameters. The other one we accept the defaults, they're much larger. Let's go back and change those to be similar size elements. 1 centimeter. Okay, make, view, turn on the mesh. Now you can see in our window here, each time we do something we get a little list of things happening. that show up on our scroll bar here. 1 centimeter, make, view. It's not necessary to view every time unless you don't trust the software. Merge body, view body, turn our mesh on. I believe this is sufficient for our current test, so I will leave it there for the moment. Stop video.